Hi, my name is Bart Stuck. I'm going to be giving a talk here on sacred geometry. This is part of what we developed in teaching a adult faith formation class at our Unitarian Universalist congregation in Westport, Connecticut over the last 3 years. And it's, as we'll see, it'll deal with a lot of things that we're dealing with at this conference, but in a different way to complement what's going on. My own background is I spent 8 years at MIT as a student and 12 years at Bell Laboratories, which was the research and development side of AT&T. I published over 30 papers and lectured at over 50 universities and research institutes in North America, Western Europe, Japan, the Soviet Union, and co-authored over 30 papers and a book on computer and communications performance analysis. I've always had an ongoing interest in mathematical physics. In graduate school in 1970, I did some work with electromagnetism, and that stayed with me, and I've come back and revisited it from time to time. And some of that will come out here in this talk today. So just bear with me. I'll try and make this as self-contained and as easy to understand as possible. But having said that, this is not for the faint of heart. We're going to be dealing with some things that are really at the crux of what's all around us, and that's really quite deep, and it's an amazing universe that we live in. So just bear with me. I'm going to start off here and try and pose a problem, and the problem I'm going to try and pose is the following. After 500 years of Western science advancing, it's realized roughly 100 years ago that a very small fraction of the universe actually has been studied. That means that if we look at all the mass and the energy in the universe, we're basically have been confined to studying 5% of it. There's another 95% that's called dark. And the piece that's called dark, 27% of it is called dark matter, which I'll explain in a second. And the remaining 68% is called dark energy, which I'll also get to. So dark, and rest assured, the best of the best are racking their brains night and day to try and figure out what in the world is going on here. So it really all starts with astronomy and the telescopes that we had. We go back in time 100 years ago. The telescopes were finally able to gather enough light so that they could see these smudges of things that they thought were just a star or two, actually were clusters of stars or complete galaxies made up of hundreds of millions of stars. And in hindsight, it became clear we live in one of these. We call it the Milky Way galaxy. And so in the hundreds of millions of stars we have in this galaxy, it turns out that it appears that a common shape for these galaxies is a spiral. So we have hundreds of millions of stars, and they're rotating around a common center. There could be some arms to the spiral side of the galaxy, but a very common thing that occurs again and again in observing through the heavens. So a very easy question to ask was, what if we just attach some average value to the mass of a star, and there's 100 million, 200 million stars in a galaxy, and so they're each attracting one another with gravitation. Okay, now they start spinning. What happens? Well, what happens is they'll all fly apart. And this suggests if they all fly apart, that we're not seeing the whole picture. there's got to be a lot more mass there that gravitationally is attracting all of these stars. We can't see it, it's transparent or it's dark. And so that's where the term dark matter came from. And roughly in the same time, it was also discovered that all of these galaxies are all moving away from each other. That meant that in particular, if we go back in time, they were all at the same place. They all started out in some common place earlier, but as they expanded out and continue to expand out, they're being pushed by some unknown energy that is in fact expanding space itself. And this energy is called dark energy. And so here we are dealing with something called dark energy, dark matter, and that's most of the story. What in the world can we say about this? So that's where we're going to be going. We're going to try and answer those questions, but the way we're going to answer them is by stepping back and looking at the actual sacred geometry that underlies everything. And that's only made possible by working with my colleague Ron Cowan, a Buddhist monk in Toronto, who for 3 years we carried out a series of observations. Ron went into intense, deep meditation and was able to become clairvoyant, and following the Yoga Sutras of Patanjali, particularly Book 3, Sutras 25, 26, 27, he was able to become clairvoyant. He was able to look down into the microcosm, into the very, very small, the atomic scale and below. And he was also able to look into the microcosm, looking out into the stars and other galaxies and so forth. An incredible gift. And it was done again repeatedly. We carried out a series of observations that led to the structure that you'll see here today. He wrote a book, it's available on Amazon, called The Path of Love, which relates to trying to turn Buddhism into an actual Western science. That may or may not be your cup of tea, but you can go to Amazon and buy the book. So let's go back over here. This is all on our website, Aleph Talks. Aleph Talks is the adult faith formation class that we put together at our Unitarian Universalist congregation in Westport, Connecticut, over the last 3 years. And the nature of this is that there's everything I'm going to have here today is going to be dealing with what's there on that website. The Aleph is the first letter in the Hebrew alphabet, so it's Aleph Talks, and it's a play on TED Talks. So alephtalks.com. TED Talks is a very popular lecture series on the web that covers all kinds of things. So here we are. So ask Ron to take a look and carry out some observations, and let's go down here. And here's an observation he carried out of an electron. So what is an electron? I encourage you to go on the web. I encourage you to look wherever you can, try and find a picture of an electron. Ron was able to do a sketch of it. He's doing this with meditation. And when he meditates, he's able to stop the electron. The electron is flying all over the place at incredible speeds. He's able to stop it, so he's able to control it, not simply being clairvoyant, but he's also leveraging his ability to control, to bring forces to bear that will stop the electron. When he actually stops it, he sees the electron is actually contained in 10 strings here, 10 closed strings. These are the strings of string theory that you might have heard of in modern physics. They do exist. And the 10 strings are vibrating like crazy, and they allow for energy to resonate inside these strings. And the resonance is so great that, as far as you're concerned, the electron is really a particle. But the resonating energy, you should think of it as kind of a jelly, but it's a pretty tough jelly. The electron actually is a torus. It's a donut. There's a hole right through the middle of it here. And these strings are wrapped around it. And that's what you have for a picture of an electron. But there's a little extra goodie here, which is that the electron's covered with blocks of information. Blocks of information. Now, the information blocks are going to, just like with any other things that involve information, you have algorithms, and then you have the actual data that the algorithms work on. So every electron has these information blocks here, and these information blocks are scanning all over the place. And if they sense any change, then the algorithms say, okay, there's change. We have to change what we're doing here to react in the following way, according to the algorithms we have built in. And so this is the ultimate computer. The fact is that we then asked Ron to take a deeper look, and he looked into space itself. If you look much smaller than the nuclear scale or the atomic scale, you go all the way down and look at space, you'll see that space is actually a foam. It's a discrete set of compartments, or a foam, and the foam the blocks of space just rub against one another. You could think of it as a fluid. The blocks of space themselves, every single space compartment has in it these information blocks. Ron looked at the information blocks, and they're in fact stacked up. Each block has a whole stack of these things. And then he saw waves occurring on the surface of these pages that you see here. We have no idea what these things are doing, but it shows how the information is moved around. And so the space itself contains all of these information blocks, and every single space compartment contains it. When we took something like the electron we had, how does it move? Well, it goes into a space compartment, and then it hops from there to the space compartment next to it, and then the next one next to it. So the notion of motion is simply hopping from compartment to compartment, and the information blocks control the motion. They control the forces that are involved, and the rules that control exactly how these hops occur from one compartment to the next. So this is truly amazing. And the blocks are always scanning all around them. So if I had to, I would suggest this is the collective unconsciousness. This is the entity that's all around us. It's in every plant, it's in every animal, it's in every rock, it's in every piece of the sun, it's in interstellar space. And this collective unconsciousness governs everything. It links everything together and makes everything work together. And now, in looking at the space compartment, though, Ron discovered that it had structure. In fact, it had 26 dimensions to it, 26 dimensions. Well, we saw before in doing our simple calculation where we had 3 dimensions, and we saw maybe 5% of the universe. So 3 dimensions, 5%, 5 is 1/20th. So 3 divided by 1/20th means 60 dimensions. Actually, there's 26 dimensions. So we're off by a little bit, but the point is there's a lot more dimensions, and that's where all the other hidden dark energy and dark matter is. Now, there's a lot of structure to this, which I'm going to go through to get across to it, but it's tricky, so just bear with me. One of the first things to keep in mind here is that we're in space and time. So we have 4 dimensions around us. We can move right and left, we can move forward and backwards, we can move up and down. So I've labeled those as X, Y, and Z. Now then we have time. And the problem with time is the time is measured in seconds or minutes or whatever, but the units are not length. These other dimensions are in length. So the first thing we have to do to deal with time is to convert it. And we use the speed of light here. It's the natural metric that we'll see. So the speed of light is meters per second, 3 times 10 to the 8th meters per second, times time in seconds. So now we've got a length, but now it's multiplied by the square root of -1. what in the world is going on here? So what I'm going to do is, just bear with me here. Let me get out of this for a second. I'm going to go over here. To this. I'm going to come back in. And we're going to try and deal with the square root of -1. We remembered from middle school, high school, we took some algebra class and we dealt with things like quadratic equations. So x squared equals 4. How do we solve this equation? Well, x squared it's squared, so I need the square root of x squared. That's x. And the square root of 4 is plus and minus 2. I have 2 roots there. That's great. But what happens when x squared equals -4? Now I take the square root of both sides, so x equals either plus and minus 2, but I still have the square root of -1 floating around. I took the square root of both sides. So the solution to x squared equals -4 is plus or minus 2 times the square root of -1. Square root of -1 is called I in mathematics. So let's digress for a second and look at this. We've got a so-called complex number. It has a real part, which is labeled here as A, and it has a real part up here, B, but the B part is multiplied by the square root of -1. That's what we have here. So suppose we just had this A here. There's no imaginary part. Now, if we multiplied A by the square root of -1, that would just take us up here. Now we're going straight up this axis. We've effectively rotated by multiplying by square root of -1. We've rotated up here. And by rotating up here, we're now perpendicular to where we started from. That's what we get out of using the square root of -1. It allows us to create extra dimensions. So let me go back to this for a second. And the thing to keep in mind here, we're trying to understand where in the world do these 26 dimensions come from. So if we go here to this picture, we see that we've got 4 dimensions, x, y, z, and then I, c, t. That gives us what we call space-time. That's the world that we live in. But time is perpendicular to all these other dimensions. So let's repeat the trick. Let's rotate all of these. Let's multiply all of them by I again. So if we multiply by the square root of -1, we're rotating all of these dimensions, then we get ix, iy, iz, and then minus ct. So we have a second subspace, 4 dimensions right next to us. In this subspace, we have where we live, and right next to us, we have this subspace for where things like our guardian angel lives. They're right next to us. They're there all the time. And the main difference is that the entities that live over here in this space here live forever, whereas the things that live over here, they're biological and they die. The piece parts of them, the atoms or the electrons or the protons and neutrons, those are around forever, but not the mental or spiritual entity. Okay, is what's missing here. Okay, so that takes care of 8 of the 26 dimensions. That gives us another 18 dimensions to deal with here. So let's look at these. The first thing we see is that they're all what are called symplectic. Symplectic means that they all have a real and imaginary part, or that they're all, if you will, these complex spaces. They're all manifolds in the sense that they all look like the space that we see locally. For example, if I'm on a sphere, which is what the Earth is, then locally it looks flat. It looks, like what's the problem? But in fact, it has curvature to it. Or I could be on a donut or a torus, and that also locally looks flat, but in fact, it's got a hole in it. So it has some different properties than the sphere, and so forth. So that's what a manifold is. And then finally, we have this term Calabi-Yau. Calabi is a Italian mathematician who proposed that these manifolds had to have certain properties, and Yau is the mathematician that proved that these things actually exist. Mathematicians do this. They don't take your word for it. You have to prove that they actually exist. And the proof was of sufficient merit that he got the equivalent of a Nobel Prize, the Fields Medal, for proving that these manifolds exist. Now, they're each of these things have six dimensions to them. So there's 3 for X, Y, and Z, and then another 3 where we've rotated IX, IY, IZ. So they each have a pairing of X, Y, and Z with an imaginary X, Y, and Z. And that takes care of what's going on here. But the thing that it talks about is they're compactified. So this is the second trick that we come up with here. What in the world is a compactified dimension? So I just got through telling you that in these compactified dimensions, for example, there's an X, here's an X dimension here that we're in, okay, and that's all well and good. And now what we have here, though, is we have the compactified dimensions. So one of them runs this way, and one of them is perpendicular and runs that way. And this is our X axis. So we have them displayed here in a plane. We're here on, think of this as a garden hose. We're walking down the X axis, and we're an ant. We walk down this thing, we just see, what's the problem? We're on a garden hose. But in fact, what's wrapped around it are these other compactified dimensions. There's another 2 dimensions wrapped around here in the example I've got here. Similarly, there's going to be, for the Y and the Z, the same sort of thing wrapped around it. And that occurs also over here for all of these other ones. So the compactified dimensions are all wrapped around the dimensions that we already live in, okay? So a totally different way to get to these unseen dimensions. But there's another thing to notice here, which is that this one here has 3 holes in it. It has 6 dimensions, but it has 3 holes. This one over here has 6 dimensions, but it has 4 holes, and this one over here has 6 dimensions that has 8 holes. So an obvious thing here is that the 3 holes here link up with 3 of the 8 holes here. The 4 holes here link up with 4 of the 8 holes here. The final 8th hole must be something to do with collecting one of these 2 6 dimensions together. So instead of actually having 18 dimensions, 3 times 6, by having these holes all connecting things, we have 10 dimensions, a total of 8 connections occurring here. So we have a 10-dimensional space of compactified dimensions. But wait a moment, I remember from Judaism in the Kabbalah, the tree of life had 10 sephiroth, 10 nodes. So the Kabbalistic mystics were able to sense the fact that there really was a 10-dimensional space here. Similarly, the Christian mystics were able to discern that there was a Father, a Son, and a Holy Spirit. Jesus of Nazareth existed here in the space-time dimensions, but his spiritual essence was here. The Holy Spirit, his guardian angel, was over here, and the Father was up here in this thing. And so we have a Trinity, the Son, the Holy Spirit, and the Father, three different subspaces, but all intimately linked together by this flow of information. And so it goes. So that's great. That takes us through all this stuff. And now we start to see that we think we're home free, but it's actually a little trickier than that. We're going to go back here now to what we saw in high school. We all remember something about a chemist coming up with a periodic table of elements. And so there's 92 naturally occurring elements, and they're arrayed here in this incredible structure, which has kept science busy for the last 100 years and will continue to do so. The first one is hydrogen, the second one is helium, the third one is lithium, and so forth. So there's this array of this periodic table of physical elements. That's great. Well, what people missed is that mathematicians are doing the same thing. They started in the 1830s and they constructed a periodic table of symmetries. In mathematics, symmetries are called groups. So let's step back for a second. Here we are in Allegan, Michigan. Mary Hardy has a pyramid here that has a base, a square, that's 2 miles on a side. And then the pyramid that is associated with that would each of the 4 sides would have an equilateral triangle with 2-mile sides. And they would be going up, and there would be similarly another 4 equilateral triangles going down. It would form an 8-sided octahedron. Now, the octahedron has a lot of symmetries associated to it. Let's look at it. First, we have the equilateral triangle on one of the sides. We can rotate that around its center 3 times, 120-degree rotations, and come back to where we started from. So that's one example. But there's a second example. Suppose we took the same equilateral triangle and we dropped a perpendicular from one of the nodes down to the opposite side base. And then we spun it around that 180 degrees. We'd be halfway around. Let's spin it one more time. So 2 rotations takes us back to where we started from. So we have 2 rotations associated with the equilateral triangle. 3 rotations takes us also back to it. And then similarly, we end up with more and more different examples of these sorts of things that are all around us. A simpler example is the cube, which is 6 squares that are each associated with one of the faces, and there's many symmetries associated with that. So mathematicians went ahead and they characterized after a period of time. It really ended around 2000, 2005, huge amount of work, 20 different categories of groups, of symmetries, 20 different categories. And that's great, except for one little zinger. There are 26 groups that don't fall into this table, into this periodic table. 26. Okay, and these 26 so-called sporadic groups, the study of symmetry led to things that are, if you will, not symmetric. These 26 groups themselves have dimensions associated with them. So hard it is to believe one of these groups, which is called the monster group, has the number of dimensions of 47 times 59 times 71, or 196,883 dimensions. That's a lot of dimensions. So we have, going down back here to our figure, for each of these 26 dimensions, we've got hundreds of thousands of other dimensions associated with each of them. What in the world does that mean? Well, one way to think about these extra dimensions is, suppose, just to keep it simple so we can visualize this, suppose we're an ant and we're in a plane. We're walking around on a plane, okay? Suppose we can raise our energy. If we can raise our energy, then we can climb up to one of these higher dimensions that we're talking about. So all of a sudden, the ant is able to go up a little higher. Well, if the ant goes up a little higher into one of these other dimensions, the ant becomes invisible to all the other ants that were there in the original plane. The ant becomes invisible. The ant can do things like walk through walls, simply because the walls aren't there. They're in this higher dimension. And again, this is all documented in the Yoga Sutras of Patanjali. These are all the tricks that you can come up with. So we have 3 different ways to create extra dimensions here. We saw the first one was rotating things, multiplying by the square root of -1. The second way was to compactify the dimensions, which we saw led to this wrapping around of the dimensions down here. And then the third way is to go into one of these sporadic groups that's associated with each of the 26 dimensions, which is up here in this table here. And that gives us the ability to resonate with the richness of the spaces that we have. We can create all the dark matter and the dark energy that we're talking about. We can create through the Holy Grail vortex. We can tap into conceptually the generator that's the Earth's dynamo, its electromagnetic field. And we don't need to create the energy, it's there, but we can control it. And in controlling it, we can end up being able to cause things to happen, such as Mary has documented time and again. Another thing to keep in mind, though, is by going in this direction that Ron Cowan did with heavy-duty meditation, he ends up being driven toward being toward happiness, toward no bad thoughts, no thoughts of hatred or anger or any other things like that. But these are all things that come out of resonating in this much higher dimensional space that's all around us. And that is the point of this. That's what we should strive for, I believe. And with that, I'm going to stop here and we'll open things up to questions. But I want to thank you very much for the opportunity to come today and give this talk. Thank you very much.